Hello and welcome to my channel. This is part 2 of timer tutorial, and we are going to see timer 2 in this microcontroller W78E052D. So the timer 2 has two registers, T2 mod and T2 con. In T2 mod there is this LSB bit DCEN down count enable. If this is 0, then the registers count only up, and if this is 1, then the registers TL2 and TH2 count both upward and downward. So timer 2 can act as a 16-bit up-down counter if this bit is set, and these are the registers TL2, TH2. This timer 2 has one more feature of capture. So the values of TL2 and TH2 are captured and stored in RCAP2L and RCAP2H. These two are the registers to capture, and the capture will occur when we give falling edge on a trigger pin. So this timer 2 has three modes: capture mode, auto reload up counting, auto reload up down counting. So these three modes we are going to see in this video. So this is the capture mode diagram. This is the auto reload counting up, and this is auto reload counting up down. So first we are going to see the capture mode. So in capture mode, when we give a falling edge on T2 AX pin and EXEN2 bit is set in the T2 con register, okay. So when this bit is set, okay, and we give a falling edge on T2 AX, then whatever the values of TL2 and TH2, they'll be captured and stored in these two registers. When this bit C, T2 bar is 1, it will count the external pulses, and when it's 0, it will count the oscillator frequency, which is 16 megahertz divided by 12. Okay, so we'll keep this 1 in our example so that we can use external clock pulses to see how this registers increment and how this capture takes place. So when this registers overflow, it triggers this TF2 flag. It sets this TF2 flag, which causes timer to interrupt, and timer to interrupt is also set when this flag is set, EXF2, when we capture. Okay, so this flag sets, which is in this T2 con register. Okay, so these two flags determine whether the timer to interrupt will be called or not. So this 2 is for UART, will not cover in this video. So we'll keep all this 0, and we have to make EXEN to 1. This LSB CP/RL2 to keep 1 for the capture mode. Then only the capture will take place. We are in the capture mode if we set this bit. Okay, so the value is 0. Okay, 0 0 0 0 1 0 1 1. So the value is 0B. So we have to load 0B in T2 con register, and in T2 mod we have to store 0 0. Because this bit is 0, we have to count up. So let's go to kill ID and see how this capture mode works. So this is the code for timer 2 in capture mode. So first we have included the header file for W78E052D. Okay. Then in the void main, we have loaded T2 mod with 0x00. And T2 con is loaded with 0x0B. So we want the third count to overflow the registers and the flag to set. So that's why I have subtracted FF by 2, and that gives me FD. So on the third count, the roll off will happen from FF to 00. That will set the flag. And then I'm starting the timer. So let's build this and debug it. So I'll go to peripherals, timer 2. Then I will open port 1. So pin 1.1 is our T2AX, which will cause the capture, and on pin 1.0 is the T2, which will increment the counter registers. So let's start this. Now we'll give an external clock pulse on 1.0 to increment the T2 register. It's incremented to FE, as you can see here. Okay. Now I'll again give a clock pulse, and now it's FF. So now I want to capture this value in the capture register. So I will give a high to low pulse on pin 1.1. And you can see that R2 cap register is now FFFF. So I've captured it, and also EXF2 flag is set. Now after FFF, if I increment the count one more, then this flag will also set TF2. Yes, this is also set now. Okay. So in this way, I can go on incrementing the counter registers. The low 8 bits make the TL2 and the upper 8 bits make the TH2. Okay, so that's why 0A right now is TL2 and 00 is TH2. So if I give a capture right now, then this value is captured in RCAP2. So 0A goes in RCAP2L and 00 goes in RCAP2H. So in this way we can capture the register values which are incrementing on the beat of a clock pulse, and its application is vast. We can measure the time interval between two events, depends upon your application. So let's move on to the auto reload mode. So this is the logic diagram for timer 2 in auto reload mode. So the values of RCAP2L and RCAP2H will be reloaded to TL2 and TH2 when we give a falling edge on T2 EX pin, which is pin 1.1. So if EX-EN2 bit is enabled in the T2 con, okay, then if we give a falling edge, then this RCAP2L and RCAP2H will be reloaded to TL2 and TH2. Or when the flag is set, when the timer overflows. So when it rolls off from FF to 00, this flag sets and it causes this RCAP2L and RCAP2H to reload. So this is a 16-bit auto reload as compared to the timer 1 8-bit auto reload. Is similar to that, but here we have the additional feature of external pin to cause the auto reload. So in this way auto reload functions. So now let's see by keeping this C, T2 bar at 1, because we want to see how the external counts increment the counter registers and how the auto reload takes place, and how giving external pulse also causes the auto reload. Okay, so we will keep this EX-EN2 bit 1. Okay, and we'll keep this C, T2 bar also 1. Now here we are not in the capture mode, we're in auto reload mode. So we'll keep this CP/RL2 bit 0. So the value is 1 0 1 0, and this all will be 0. So T2 con will store 0A. 8 plus 2 is 10, and 10 is A in hexadecimal. So the value will be 0A to be stored in T2 con register. T2 mod will hold 0x00. So now let's write a code and see how this auto reload works. Then we'll write a delay function in the kill IDE. So now let's write a code to set timer 2 in auto reload. So T2 mod is equal to 0x00. So this registers T2 mod and T2 con are specific to W78E052D. So make sure you have included this header file. And T2 con is equal to 0x0A. So now we will load TH and TL. TH I will load with FF, and TL2 I will load with 0xFD because we want on the third count the flag to set. RCAP2H I will set to 0xFF. So first I will set RCAP2H to 0xFF, same as TH2, and RCAP2L I will set same as TL2, 0xFD. And now I will start the timer. TR2 is equal to 1. So what this will do is initially we will load TL2 and TH2 with 0xFD, FF and FD, and the same value we're loading in RCAP2L and RCAP2H. So when the reload flag sets, the reload will take place, and after every third count it will again go FD and it will roll on. So let's see whether that works or not. So I will toggle port 1.0. Now I will run the code. And T2 is loaded with FFFD. So FF is TH and FD is TL. RCAP is also loaded. So now I will give a clock pulse to increment the T2 register. So it's incremented to FE. And now on the third count, the RCAP value must be loaded to T2. See, now T2 is loaded with FFFD. Now again on the next clock pulse, it will roll from FE, it will go from FFFD, and this cycle will repeat. So in this way the auto reload works. So this can be used to generate precise delay. So in timer 1 we generated the delay in the similar way we can generate delay in timer 2 using this auto reload feature. And also if we give a falling edge on T2EX pin, you can see that the capture takes place. Suppose we want the reload to occur on the external trigger pulse, and that feature is also there in this timer. Now let's write a delay function. So we want a base delay of 1 millisecond. Okay. So the maximum count here is 2 raised to 16, which is 65536. So on 65536, the flag will set, means the roll off will happen from FF to 00. And we want a base delay of 1 millisecond. So 1 divided by 0.750. So 0.750 is the time period for 16 megahertz divided by 12. That gives us 1.33. So if we subtracted 65536, which is the count on which the flag will set, minus 1333, we get 64203. So I have to convert this value to hex. So in hex it's FACB. So FA goes in TH2, CB goes in TL2. In similar way, RCAP2H also holds FA and CB. And we want to count how many times the flag is set. So let's write a delay function. This is a function to generate delay using timer 2 in auto reload. So first we declare a variable C, unsigned int C, to count how many times the flag is set. Then T2 mod is equal to 0x00, T2 con is 00. Then we load TH2 with FA and TL2 with CB, RCAP2H with the same value as TH2, RCAP2L with the same value as TL2, CB. Then we start the timer. Then we wait and we check whether C is less than T or not. And that many times the loop is repeated. So if T was 3, it will go from 0 to 2. So it will wait till the flag is set. Once the flag is set, it will clear the flag, increment the count by 1. That means the flag was set once, and then it will go till C becomes greater than T. And once that, we are out of the loop and stop the timer. And we are generating a delay of 10 milliseconds. We'll blink a LED, okay, at the output. Now let's see the waveform in the debug. So T off is approximately 10.0 millisecond and T on is also 10.06 milliseconds. So yes, we are getting precise delay as we are not wasting any machine cycles. So now let's move on to timer 2 in auto reload, counting up and down. So we can use it as a 16-bit up-down counter. Let's see how to do that. Let's configure the registers to do that. So this is a logic diagram for timer 2 in auto reload, counting up and down. So to enable the down count, we have to set this bit DCEN in the T2 mod register. So the value of T2 mod will be 0x01. So in this mode, if we set this T2EX bit to 1, this will act as a up counter. Suppose rcap12 and rcap2h is loaded with 6. Okay, so start the timer and pass the counts, and TL2 and TH starts to increment. Okay, and when it overflows from 65535, it will reload the contents rcap12 and rcap2h back to TL2 and TH2. So 6 is loaded again, and the counting will start from 6. Okay, on each clock pulse it will increment and it reaches 65535. The cycle repeats. So every time this counting registers overflow from 65535, it will set this flag TF2, and also it will toggle this EXF2 flag. So if we toggle a pin on this flag EXF2, it will act as a frequency divider. So whatever frequency we give on T2 pin, square wave frequency, will be divided by N. The value to be loaded in rcap12 and rcap2h will be 65536 minus N, converted into hex and stored in rcap12 and rcap2h. That will give you divide by N frequency at the output of the port pin, which is toggling on this flag. So that is one of the application. Suppose this pin is set to 0, this registers decrement. So initially this is 0. In the next clock pulse it will decrement to 65535, and the down counting goes on until the match occurs. Okay, so when the contents of TL2 and TH2 match rcap12 and rcap2h, which is 6, while counting down, when the match occurs on the next clock pulse, it again reloads FFFF back to TL2 and TH2. Now the counting starts from FFFF. Down counting starts from there. So when the match occurs, again the cycle repeats. So in this way, here when the match occurs, after the match the flag is set and the EXF2 flag is toggled in down counting. So in this way this works. Now let's load the values. So as we are using external clock pulse to see how the counting registers increment, we will set this bit to 1. Okay, so T2 con will be 02 and T2 mod will be 01. So let's write a code in Keel IDE. So now let's write a code for timer 2 in auto reload counting up and down. So I've included the header file. I've connected one LED to pin 1.3 to show the status of the EXF2 flag. T2 mod is equal to 0x01 because we want a down count enable bit to set. T2 con is equal to 0x02 because we are using the external pulses to increment the counting registers. Now TL2 and TH2 form the 16-bit register. So I want to convert it into a 3-bit counting register, because if I use 3 bits, I can use only 3 LEDs to show how the counting works. So I will subtract 65536 minus 8. On the 8th count, the flag will set. So 65528 gives me FFF8. FF goes in TH, and F8 we will store in TL2 0xF8. So in this way I can transfer TL2 to port 2 and show you how the up counting and down counting works. rcap2h will store the same value as th2, and rcap2l will store the same value as th2. Now we'll start the timer. tr2 is equal to 1, and now I want the status of EXF2 flag to be continuously updated on this LED pin. Okay, so I will write LED is equal to EXF2. So this is a bit addressable register T2 con, that's why we can directly use EXF2 and put it into the LED. So in the next line we will put TL2 on port 2, and then I will give a delay of 100 milliseconds. So this delay function uses timer 0 in mode 1. This is nothing to do with timer 2. So we can use this delay function here. So in this mode we will not use the debugger. Instead we will upload it directly to our microcontroller and see the practical output on the breadboard. So let's create the hex file and upload this So yes, the code is uploaded. Now let's see the output on the breadboard. So the code is uploaded, and what you can see here is this 3 LEDs, which represents the last 3 bit of the TL register. So we put TL2 on port 2. This is port 2. These are the last 3 bit of the TL2 register. This is the LSB012. So TH2 and TL2 form the 16-bit register. And these are the last 3 bit of that register, as we are using only 3 bits to count from 0 to 7. So this is the T2EX pin. I've connected to 5 volts. So this acts as a up counter. And this is the T2 pin, to which I've connected one button. And I'll press this button. It will make the pin low, which will cause the counting registers to increment. So the LEDs are connected in common anode. So all these were 0, 0, 0. So if I give one count, it will increment and it will become 0, 0, 1. So this is 1. Then 0, 1, 0, which is 2. This is 3, 4, 5, 6, and 7. 7 means all 1. This is FF, FF. So after FF, FF, if I give one count, it will overflow. So this T2EX flag, which is represented by this LED, will toggle. So this will go low. So now I will use it as a down counter. Okay, so I have connected T2EX to 0. On the next count, this is 0, 0, 0, 0. It will become FF, FF. So this is 6, 5, 4, 3, 2, 1, then 0. In the next count, this will toggle 6, 5, 4, 3, 2, 1, and again 0, 0. So after 0, 0, 0, after F8, it again reloads the FFFF in down count. So this rotary encoder shifts 1 when we rotate it clockwise, and it shifts zeros when we rotate anti-clockwise. So what if we connect this data pin to T2EX and clock pin to the button pin? So we can use it with a rotary encoder. So in this way, right now it's 0, 0, 0. If I rotate the shaft clockwise, so it becomes 7, 6, 5, 4, 3, 2, 1. So rotating the shaft clockwise is counting down, and rotating the shaft anti-clockwise is counting up. Okay. So in this way, we don't need a code for this rotary encoder if we are using timer 2. You can just initiate the resistors, directly interface this rotary encoder to T2EX pin and T2. And we can use this rotary encoder. So this is one of the application of timer 2 in auto reload up down counting. And we can pass this TL2 and TH2 values directly to our application function and control a LED or anything we want with this 16-bit output. So this was the video. I hope you enjoyed it. For more interesting electronic videos, like this video, subscribe to my channel, share it with your friends, and thanks for watching.